All right, so quick review on ionic bonding, and then you have a quiz, a small quiz. So for that on your Schoology, there's this flow chart, right? So if you kind of get lost, you can use this flow chart. It shows you how to name ionic or covalent. Remember, we haven't done anything with covalent yet, so you should not be on this side of the, let me use my little lighter thing. You should not be on this side of the flow chart. You're only on this side, okay? We've talked about how to name if it's a metal and a non-metal. We've talked about how to name if it's polyatomic, okay? Today we're going to talk about how to name if it's two polyatomics, which is only one in particular, okay? And we're going to touch base on how to write, well, that's it for that. Then on the second page is how do we write formulas? Again, we're not on the covalent side. We're only on this side, okay? We're going to talk about, so we've already done charges. We said you have to get it to 0, okay? And today we're going to talk about also how to do it. If I give you something like a metal like this, and I give you this little Roman numeral behind it, so we're going to talk about that really fast as well, okay? But this again is on Schoology. The name of it is naming and writing formulas for ionic and covalent compounds, FC, which stands for flow chart. Okay, FC, which stands for flow chart. All right, so I'm going to do just a little bit of practice, and then you're on your own. Okay, just a quick review. All right, so here, just as a reminder, you have a Chem Cruncher on Schoology, okay, and your Chem Cruncher has everything you need on it. So it looks like this, okay. So one side is the periodic table, and the other side is all of this stuff which you need, which right now you just need the polyatomic ions. So that's what you need that for, okay. But this is on Schoology. It's called a chemistry cruncher. That's what I named it, okay. It's almost in every school. All right. So now let's just refocus again and talk about the different ways you can have an ionic compound. Okay, the different ways you can have an ionic compound. Here's how you can have an ionic compound. You can have a metal bonded to a non-metal, which means you need to know where metals are and where non-metals are. Okay. You can also have a metal bonded to a polyatomic. All right. Polyatomics are these guys over here, polyatomic ions, okay? The other thing you can have is a polyatomic, specifically NH4, okay, bonded to a non-metal, or you can have NH4 bonded to a polyatomic. These are the two we haven't talked about, all right? So NH4 is a polyatomic ion, but it is positive. So if you notice, when we were talking about polyatomic ions the other day, all of them are negative. These have a -1 charge. These have a -2 charge. These have a -3 charge. There's only 2 that have a positive charge. They're down here, okay? And one of them we probably won't talk about because it has more to do with acids and bases, so you don't have to worry about this one. All right, but the one above it, ammonium, you need to know it. If I am circling it or highlighting it, you need to know it, okay? If you ask me later on the quiz, what is ammonium? I would say you should have wrote it down because you need to know it, all right? Ammonium is NH4 with a +1 charge. NH4 with a +1 charge. NH4 with a +1 charge. You need to know that. I will probably write it down, okay? NH4 with a +1 charge, and it's called ammonium, okay? As a reminder, when we're looking at these polyatomics, I don't want you to worry about the subscripts on these, like these little numbers, because that's part of it. It has nothing to do with it has nothing to do with you when you're using the charge, okay? So you don't have to do any extra math. NH4 is like saying, okay, it's like saying my name is Peyton, but if I try to take off the 4, it's like taking off the N on my name. My name's not Peyton or Peyto, it's Peyton, okay? So NH4 is a nitrogen with 4 hydrogens attached to it, okay? If you take away one of the hydrogens or try to add extras, then it's not ammonium anymore, okay? So you don't have to worry about, just make sure you don't try to change anything about that, okay? All right, so you need to know ammonium, okay? That's the one you need to know. Now, ammonium has a +1 charge. We compare it with a non-metal, okay? Or we compare it with a polyatomic. Those are also ionic. So for example, it's still the same thing. We're not gonna name it any differently. We're not gonna do the formula any differently than what we've already been doing. So for example, if I told you ammonium oxide, okay? We're gonna figure out the formula for it the same way we would do anything else. Can somebody tell me, everyone should be able to tell me, what is ammonium and what is its charge? What is ammonium and what's its charge? Yes, it is NH4. Thank you, Luis. And what is the charge for it? +1. Excellent. All right. How about oxide? It is a -2 charge, and I didn't hear you. What did you say the symbol is? Oxygen. Oxygen. So it's just O. Okay. Now remember with ionic, we have to get those charges to cancel out. They have to be equal to 0. Okay. Are they equal to 0 right now? If I add them up, +1 and a -2, is that equal to 0? No, it is not. Do I need another oxygen or another ammonium, or do I need some of both? Another ammonium. All right, so I'm going to add another ammonium. NH4 with a +1 charge. That is now equal to 0. So when I get ready to write the formula, okay, when I get ready to write the formula, all right, remember it is just you telling me how many you got of each. That is where the subscripts come in. Subscripts, sub means under, so those are the little numbers that sit below the letters, okay? So NH4, and we had 2 of them, NH4, 2, and then we have 1 oxygen. Now, what looks weird about this NH4 2? What does it actually look like? To me, it looks like, it looks, why does this look weird, this NH4 2? Does it look like 2 NH4s?
It looks like NH4.
Yeah, it looks like NH42, okay? That's what it looks like. So remember, if you are saying you have more than one polyatomic, so that it looks like it stays together, we're gonna put parentheses around it. So I'm gonna put parentheses around here, and now it looks like 2 NH42s, okay? Or 2 NH4s, okay? So the answer to this one is NH4 2O. The parentheses show me that I have 2 of those instead of it looking like 42, okay? All right, so that is ammonium oxide, okay? So that is how we could put ammonium with a non-metal. Let's put ammonium with a polyatomic, okay? I'll even be nice and not erase most of this stuff, okay? All right, so let's do ammonium polyatomic. Okay, so let's pick a polyatomic. Now, let me remind you and give you a hint, okay, that you would need for your quiz, okay? So if it is a polyatomic, okay, here's how you know it's a polyatomic, okay? Most of your polyatomics, with the exception of like 3 or so, at least on this chart, end in 8. Acetate, bromate, iodate, nitrate, perchlorate, pyridate, thiocyanate, chromate, phosphate, or they end in ite, okay? Chlorite, nitrite, sulfite, phosphite, okay? There are only a handful of these, like 3 of them, that don't end in ite, okay? And there's cyanide, that ends in IDE, hydroxide, and peroxide, okay? Other than that, if it ends in IDE, It's one of these guys over here, okay? One of these guys, okay? So the IDE tells you it came from the periodic table. The 8 or I tells you it came from the back of the periodic table, which is the polyatomic, okay? That's important because on some of the questions I may say, hey, how do you know this is ionic? And you have to tell me, well, it's a metal and it's a polyatomic, or it's a metal and it's a non-metal, or maybe it's two polyatomics like we're about to do right now. All right, so ammonium, and let's do, how about ammonium and, how about ammonium carbonate? All right, so I said 8, so that should tell you it's coming from this table over here. So find carbonate and tell me the charge for it. Yeah, it should be on that table, carbonate, carbonate. Anybody find carbonate and tell me what the charge is? So did you pull that from the periodic table? Okay. If you pull from the periodic table, remember it should end in IDE. But I said carbonate. Somebody online, tell me what carbonate is, please. I can pick someone.
I see carbonate versus hydrogen.
No, there's another one. Keep looking. Teresa, do you see carbonate? You guys should be looking for it. Everybody should be looking for it.
It's negative.
Teresa, do you see carbonate? No, Teresa. Gibson, do you see carbonate?
On the periodic table,
Well, it ends in 8, so what does that tell you?
it's gonna be on the right side, right?
Correct. So see if you can find it. Carbonate. See it?
We're supposed to go on the left.
Yeah, so this is, we're doing ammonium carbonate. I just didn't erase the ammonium since we already had it up there. Gibson, did you find carbonate yet?
No, ma'am.
Are you looking over here?
Yes, ma'am. I see the HCO. Is that what we're looking for?
Nope. So there's another one. Keep looking. You're close though. There's another one and it doesn't have the hydrogen.
Oh, I see it.
See it?
The CRO -2,4. Yeah.
Excellent. All right. So he said CO. What'd you say? Say that one more time.
CRO -2,4.
Up close. Not chromate.
Oh.
Carbonate.
CO, would it be a -2 on top and 3 on the bottom?
Yes. CO3. You see, it's right here, Gibson. You were just down one. Carbonate. You're giving me chromate, Gibson. All right, so there's carbonate. So now, same thing. We need to get these charges equal to 0. Do they equal 0 right now? No, Miss Payton, they don't. What do we need? Somebody tell me what we need.
You got to find the LCM, right?
Yeah, you can. Yep. So you got, this one has a +1 charge, and this one has a -2 charge. So what do you need? Do you need more carbonates, more ammoniums?
Ammonium.
Another ammonium, exactly. So I'm going to do another ammonium over here. +1 charge. That one now equals 0. So I want 2 NH4s. Okay. Remember, I'm going to put parentheses around it so I can say that I have 2 of those. And then a CO3. Okay. All right. So that covered NH4 with a polyatomic. And before that, we did it with a non-metal. And the other days, we have been working on metals with a non-metal and metals with a polyatomic. So I'm going to teach you one last thing, and then You're gonna work on your quiz, okay? All right, I'm gonna clear everything. Clear, clear, clear. All right, so on your quiz today, there's going to be, okay, there's going to be a part where it is asking you to find something that we haven't done before. Your Roman numerals, okay? The next part that we have to know is Roman numerals for the last thing. Because what we've been doing right now is we've been focused on all of the metals here, okay? And then we did aluminum as well. But we haven't really messed with the metals. Okay, why is this moving? Sorry. Okay. All right, but we haven't really done anything with the metals that are right here. Okay, we haven't done anything with the metals that are right here. And that's because their charge can change. Okay. I have to tell you what the charge is in order for you to figure out what the formula is. Okay. I have to tell you what the charge is. So we're going to do some of those. So hopefully you know your Roman numerals. If not, by the end of today, you should, because there's a question on your quiz about it. All right. So we're going to do one of those. But once I tell you what the charge is, it's literally the same thing. Okay. So there are also a couple of charges that I did not tell you that you should know. So write these down really quickly. All right. So we've done aluminum. Somebody tell me what the charge for aluminum is.
+3.
+3. Thank you. All right. Here's the other one you need to know. Zinc. Zinc's charge is always +2. And then silver, his charge is always +1. So you need to memorize those three. Okay. Zinc is +2, silver is +1. Now we're going to start dealing with all these other guys. So for instance, I'm going to start with an easy one. Well, we'll start with this one. All right, I'm looking at this question right here. Iron 2 bromide. Now, again, if you see anything and it has these Roman numerals, okay, that is a sign that it is coming from somewhere around here, okay? You may get a couple that are like down here or something, but mostly from right in here, all right? So this one says iron, what's that Roman numeral?
2.
2.
Yes, it is 2. Iron 2 bromide. All right, so somebody tell me, so I'm gonna write this, iron 2 bromide. All right, iron, somebody tell me the symbol for iron. Fe, excellent, okay? Fe is the symbol for iron. This 2 tells me his charge. Is that a +2 or a -2? It is positive because the first one is always positive when we're doing ionic. It's always positive first. All right, so +2. All right, now what about bromine or bromide? Br, what's the charge? Negative something. -1, excellent. Now we can get the formula for this, okay? Now we can get the formula for this. Charges do not equal 0 yet. Do not equal 0 yet. Someone's telling me in the chat the answer. They're probably, oh, never mind, they're not telling me. All right, Fe with a +2 charge, Br with a -1 charge. Somebody can either tell me what my end formula would be or what I need to add. Excellent. Kay said we probably need another bromine. I bet somebody's telling me in the chat. Yep, good job, Chloe. All right, so we need to add another bromine, Br -1. So now we can write our formula. We need Fe, one of those, and then we need 2 Brs. So I'm going to put a 2 right here. FeBr2. All right, let's do another one. How about number 7, copper 2 sulfate, copper 2 sulfate, copper 2 sulfate. right, copper 2 sulfate. We need to find copper. We know his charge. What is copper's charge?
+2.
Excellent. +2. Anybody find the symbol for copper yet? It's not CO, I'll tell you that. CO is cobalt. But it
Yeah.
is near that.
See you?
See you, absolutely. See you later, copper. That's what we say. See you later, copper. Okay. So that's Cu, and then sulfate. Now listen carefully. I said sulfate. 888. Anytime you hear 8, you should be thinking that you should be looking at polyatomic. Excellent. Okay. So somebody find sulfate and tell me the charge. Sulfate.
SO -2 4.
SO4, yes, with a -2 charge. So that's how we'll read these. Like this one, I would say HCO3, and then I say -1 charge, or SO4, -2 charge. Excellent. SO4, -2 charge. Do these equal 0?
Yes.
Yes, excellent. That's the formula, CuSO4. All right, one more. Two more. Okay. How about number 11? Number 11. All right. Number 11 says manganese, not to be confused with magnesium. Manganese, and it has this Roman numeral, and then it says oxide. Oxide. Okay. Manganese, Roman numeral, oxide. Let's see. Mandy, how about you give me oxide? You can tell me the symbol and the charge.
Oh,
Uh-huh.
and would you want the number?
The charge. So the number I'm gonna write up here, plus or minus something.
-2.
Excellent. -2. -2. All right. Anybody found manganese? Not to be confused with magnesium. It's not magnesium. And remember, if you see a Roman numeral, it's somewhere in the middle, probably.
Is it MN?
Yes, it is. Mn. Anybody know what the charge is? That means you need to know what this Roman numeral is.
+3.
Excellent. +3. All right. I think we need a couple more of both of these. Anybody just got the final answer for me? I'll go back and do it though. I need subscripts, which are these little numbers down here.
2 and 4 or 3, sorry.
Excellent. 2 and 3. I need 2 MNs completely. All right. And then I need 3 oxygens. All right. So this is MN2O3. Excellent. All right. Any questions? All right. When we come back, we have one more thing to learn, and that's how to go backwards. So if I give you, for example, and I'm going to save that. So for example, if I give you Mn2O3, you have to go backwards and tell me manganese 3 oxide. So we'll save that for after the break. But you should be able to do everything else, okay? All right, so I'm going to